Welcome to the Mathematics in my channel. In this video, we are going to solve this integral. So what do you think about this integral? Easy one? Actually, at first glance, I thought this was very easy. But suddenly, I remember the integrals that we evaluated in previous videos. Integral from 0 to pi over 2 x over sine of x, and we proved this is equal to 2 times g we know Catalan's constant. Also we evaluate this integral from 0 to pi over 2 x square over sine of x dx, and this is equal to we prove this is equal to 2 pi g minus 7 over 2 theta of 3 So in these two integrals we know the answer with 2 times g, here 2 pi g, so answer with Catalan's constant. So here if we look at this integral, here we have x square, so in the numerator here also x, and here in the denominator we have sine function. So I think the Catalan's constant involved at the end. Okay, let's begin. Well, here now we have 0 to pi over 2, but here we have 0 to pi. So I'm going to break the limit 0 to pi over 2, x square over 1 plus sine of x perfect square dx, plus then here pi over 2, so pi over 2 to pi x square over 1 plus sine of x square dx. Okay, now for first integral, this integral I am going to use King's property. We know the King's rule. Integral from 0 to a f of x dx is equal to integral from 0 to a f of a minus x dx. So we can write this is equal to 0 to pi over 2. Now instead of x, pi over 2 minus x, so pi over 2 minus x perfect square over here 1. Now sine of pi over 2 minus x, we know cosine of x, so 1 plus cosine of x perfect square dx. Okay, now for this integral, now we need to limit from 0 to pi over 2. Therefore we can take a substitution. X is equal to pi over 2 plus u. So now if we differentiate, we have dx is equal to du. Now we need to change the boundary, lower limit. When x approaches to pi over 2, we know u approaches to 0. Upper limit, when x approaches to pi minus pi over 2, we know pi over 2, so 0 to pi over 2. Now x square, x we know pi over 2 plus u, so pi over 2 plus, now here we have u, but we know the definite integral independent of the variable, so we can plug in x instead of u. So here x, here 2, and here we know sine of pi over 2 plus u, cosine of u, so we can write 1 plus cosine of x square dx. Then we have same limit 0 to pi over 2, also same denominator, so we can write now this is equal to 0 to pi over 2, here pi over 2 minus x perfect square plus pi over 2 plus x perfect square over 1 plus cosine of x square dx. Well, now we can simplify the numerator, so 0 to pi over 2. Now 5 square over 4, here also 5 square over 4, we know 5 square over 4 plus 5 square over 4, 5 square over 2, then here x square, here also x square, so plus 2 times x square. Now middle term we know minus pi x, and here plus pi x, minus pi x and plus pi x get cancelled. So here we have 1 plus cosine of x square dx. Okay, now we can simplify the denominator. So we know cosine of x we can represent as a half angle. So here 2 times cosine square of x over 2 minus 1. Therefore we can write our integral is equal to integral from 0 to 5 over 2 here 5 square over 2 plus 2 times x square over, now here 1 plus cosine of x we know 2 times cosine square of x over 2 minus 1. So 1, this minus 1 get cancelled, here 2, so 2 square we know 4, so 4 times cosine raised to the 2 power, but here raised to the again 2 power, so cosine raised to the 4 power of x over 2 dx. Here we have x over 2 half angle, so I am going to take another substitution. X over 2 is equal to t, x over 2 is equal to t, then differentiate, so dx is equal to 2 times dt. Now we can plug in here, so we can write I is equal to now limit we know when x approaches to 0, lower limit t also approaches to 0, upper limit when x approaches to pi over 2, t approaches to pi over 4. Okay, then here 5 square over 2, so 5 square over 2 plus 2 times x square we know 4 times t square, so here we have 8 times t square over here 4 times cosine raised to the 4 power of t, and dx is equal to 2 times dt. Now we know these 2 get cancelled, and here we can divide by 2, so we can write integral from 0 to 5 over 4. If we divide by 2, here we have in the numerator 5 square over 4 plus 8 over 2 we know 4 times. Now instead of t also we can use x, so here x square over cosine raised to the 4 power of x dx. Now how to evaluate this integral? Okay, let's use IBP, integration by parts. So we can write integral from 0 to pi over 4 as a first function. I'm going to take the numerator, so 5 square over 4 plus 4 times x square d by dx. Now integration of 1 over cosine to the 4th power of x. So how to evaluate that integral? Okay, integral of dx over cosine to the 4th power, so we can write this is equal to secant raised to the 4th power of x dx, and we can use a substitution. V is equal to tan of x, then differentiate, dv is equal to secant square of x dx. Now we can write our integral is equal to secant square of x. Secant square of x we know 1 plus tan square, so 1 plus v square, then again secant square of x dx we know dv. Okay, then if we integrate this we know we have 1 plus v cube over 3 plus c. Now v is equal to we know now v is equal to tan of x, so we have tan of x plus tan raised to the 3 power of x over 3 plus c. Therefore here we have tan of x plus tan cube of x over 3 dx. Well, then we know product of these two functions, so we have 5 square over 4 plus 4 times x square times tan of x plus tan raised to the 3 power of x over 3 from 0 to pi over 4, then minus integral from 0 to pi over 4. Now rewrite this function, so we have tan of x plus tan cube of x over 3, then derivative of first function we know 8 times x, so 8 times x dx. Okay, now if we apply limit here, we know here we have 5 square over 4, here 5 raised to the 5 square over 16, but here 4, so 5 square over 4 again, and here we know tan of 5 over 4 1 plus 1 over 3, so 4 over 3, so we have here 2 pi square over 3, 2 pi square over 3 minus here we have 0 to 5, here 8. Now we can split this integral into different integrals after multiplication, so we can write here minus 8 times x times tan of x, so integral from 0 to 5 over 4 x times tan of x dx, and again minus 8, but here 3, so minus 8 over 3, minus 8 over 3 integral from 0 to 5 over 4 x times tan cube x dx. Okay, now let's take this integral is equal to j1, and this one is equal to j2, so we can write now I is equal to 2 pi square over 3 minus 8 times j1, then minus 8 over 3 times j2. Okay, then we need to evaluate j1 and j2, so let's take j1. So j1 is equal to integral from 0 to pi over 4 x times tan of x dx, x times tan of x dx. So we can use IBP, integration by parts, so we can write 0 to pi over 4 as a first function. I am going to take x, then d by dx. Here integration of tan of x we know minus natural log of cosine of x dx, then product of these two functions, so minus x times natural log of cosine of x from 0 to 5 over 4, then minus, but here minus, so plus integral from 0 to 5 over 4 natural log of cosine of x times derivative of x we know 1, so cosine of x dx. Okay, now here if we apply limit 5 over 4, so here minus 5 over 4 natural log of, now cosine of 5 over 4 we know 1 over square root of 2, so we can write 2 to the minus 1/2, then 0 to pi over 4 natural log of cosine of x dx. We evaluated this integral in a previous video. I will add the link in the description, and the answer is plus g over 2 Catalan's constant minus 5 over 4 natural log of 2. So here this minus 1/2 we can write here, so minus minus plus 5 over 8 natural log of 2, but here minus 5 over 4 natural log of 2, so we can simplify here g over 2, so g over 2 minus 5 over 4, 5 over 8, so minus 5 over 8 natural log of 2. Okay, this is the answer for j1. we need to evaluate j2. Okay, let's evaluate j2. This is j1. Now we are going to evaluate j2. So j2 is equal to integral from 0 to pi over 4 x times tan raised to the 3 power of x dx. Okay, for this integral also we can use IBP. So we can write integral from 0 to pi over 4. Now as a first function I'm going to take x, then d by dx, then here we need to integration of tan cube of x dx. So let's evaluate integral tan cube of x dx. Now we can write this is equal to sine raised to the 3 power of x over cosine to the 3 power of x. Sine raised to the 3 power of x we can write I'm going to write sine 3 of x. We can write sine square of x times sine of x. Sine square of x we can write 1 minus cosine square of x, then here sine of x dx over cosine raised to the 3 power of x. Okay, then we can take a substitution. So u is equal to cosine of x. U is equal to cosine of x. So we know du is equal to minus sine of x dx minus sine of x dx. So we can write now here 1 minus cosine square u. So 1 minus u square sine of x dx we know minus du. So sorry, here minus du over u to the third power. Now we can simplify this. We can multiply by minus sign and also divide by u to the third power. So we can write this is equal to integral u square over u to the 3 power. U square get cancelled, so 1 over u minus 1 over u to the third power du. So here we know natural log of u we know cosine of x, then minus here minus, so plus 1 over 2 times u square we know cosine square of x plus c. Okay, now we can write here integration of tan cube of x is equal to we have natural log of cosine of x plus 1/2 1 over cosine square we know secant square of x dx. Okay, then we know product of these two functions. So we have here x times natural log of cosine of x plus 1/2 secant square of x from 0 to pi over 4, then minus integral from 0 to pi over 4 we have natural log of cosine of x times 1/2 secant square of x times derivative of x we know 1. So now again we can split this integral to different integrals. So 0 to pi over 4 natural log of cosine of x dx, natural log of cosine of x dx plus 1/2. So here we have minus, so minus 1/2 integral from 0 to pi over 4 secant square of x dx, secant square of x dx. Okay, now if we apply limit here we know x 5 over 4, so 5 over 4 natural log of cosine we know 1 over square root of 2, so 2 to the minus 1/2 then plus 1/2 secant square of x we know 2, then here minus 0 to 5 over 4 natural log of cosine of x, again we know this is equal to g over 2 minus 5 over 4 natural log of 2. So here minus g over 2 plus 5 over 4 natural log of 2, and here we have minus 1/2 integration of secant square of x. We know tan of x from 0 to 5 over 4, tan of 5 over 4 we know 1. So we have now j2 is equal to 5 over 4. Sorry, now here we have natural log of 2 to the minus 1/2. So we know 5 over 8 minus 5 over 8 natural log of 2, but here 2 get cancelled and 5 over 4. So 5 over 4 minus 5 over 8 natural log of 2. So we can write 5 over 4 minus 5 over 8 natural log of 2, then minus g over 2 minus g over 2, then plus 5 over 4 plus 5 over 4 natural log of 2 minus 1/2. Okay, then here we know we can simplify this. So we have 5 over 8 natural log of 2 minus g over 2 plus 5 over 4 plus 1/2. Okay, now we know our integral I is equal to 2 square over 3 minus 8 times j1 minus 8 over 3 j2. So we can write 2 square over 3 minus 8 times j1. So 8 times g over 2, 8 times g over 2, then minus plus 8 get cancelled. So natural log of 2, then minus 8 over 3, now g2. So here we have 5 over 8 natural log of 2 minus g over 2 plus 5 over 4 minus 1/2. Okay, now we can simplify this. So if we simplify this, here we have 2 square minus 8 times g, so minus 8 times g minus 2 times pi plus 2 times pi natural log of 2 plus 4 over 3. Okay, this is the answer. Thank you for watching.